Hello, welcome to my bench. Today we've got a 528E that we're going to do a full recap and switch replacement in real time. I got this one in and several others to fix, and I thought maybe you'd like to see how this whole thing works out. I've come up with what I think is probably the absolute best method for doing this. I start off by taking the little side cutters, the little nippers, and chopping right down to the board all the leads on all the capacitors, because when they put the caps in, they pinch the leads so they don't fall out. And since the holes that they drill in the boards are so small that they just fit the leads, if you try to pull them out without doing this, you'll rip the vias right out. Then, after I get all those done, I'll go through and clip all of the leads off the bottoms of all of the switches. I don't even bother testing the switches anymore. I just change them out. This makes removing the switches a lot easier. It's just, I've tried every method in the book to try to get these things out, from hot air, which ends up buckling up the board, to solder suckers and solder wick and everything you can think of. And when we get down here at the end, after I get done with all of this, you'll see how I take them out very easily. I'm not going to talk all the way through this because, quite frankly, it would get really boring. So I'll just lay some music down underneath it and interject stuff as it needs to be. Right here we've got, you can see that trace is really close to the leads on that switch. So you got to be really careful. And later on, when you're taking it off, you have to be really careful too. One of the problems with these 528Es is they made the smallest traces that you can imagine running around this board. All this room they had, and they made just the tiniest little traces. So we got all the leads clipped off, or at least I think we do. And it's time to start removing a few. I'm going to start by tinning the leads of the capacitors that I'm going to take out. I'm going to start with the 1000 microfarads of 50 volts. These are the ones that are really picky. If you don't clip the leads, you will every time rip out the bottoms, rip the vias right out of the holes. So we just heat them up, rock them back and forth a little bit. You can feel them let go. And just a little bit more, and there you go. There's the first one out. Go over the second one here. And rock it back and forth. You can just walk it out of the holes, and pretty soon it'll fall out too. Sometimes it'll fall right out on the bench. There we go. And then from there, you want to suck the solder out of them. I have a mechanical or a solder sucker. On these big ones, it's best to put a little bit more on there, and that way it gives the air solder sucker something to work with. It's not perfect, and it sure isn't a good one, but it works. It's not real great. I found out for actually using it to get the leads, the whole capacitor out. Sometimes you have to add a little bit more heat to it, especially on the big ground pads in the middle where it just sucks up the heat out of this thing and it just can't handle it. But that looks pretty good, I think. we'll see when I go to put the new ones in. We got 2 more on this end that are really the big fat leads. Now the problem here is that this one I'm working on right now, it has there's no traces on the bottom. Both traces are on the top, and I try very hard to get as much out of there as I possibly can to start with, and it's very difficult. You got nothing to heat up except a little teensy pad, and your chances are very good that you will rip that pad right off the board, both of them. But I do it this way because sometimes it works good enough that I can just pull them out, but not generally. Like I said, the leads are just barely fit in the holes the way they are. So you'll see here in a minute what happens to it. Well, I guess that's enough messing around with that, trying to get it sucked. It's just not working. I cannot get it out of there, so we're just going to have to wiggle them out. And this part scares me because, like I said, these things are not on here. The pads are not on well, and I guarantee you I'm going to lose one, if not two. Got that one out finally, but it's just, this is by far and away the hardest set of caps to get out of here. There's another version that only has one capacitor that goes in there, but you don't see very many of those. This one's from '98. There's the other one. Anyhow, it's not the prettiest thing on earth. Should be able to at least clear the holes now, I hope. Yeah, I'm sure I pulled a pad off. But it's not connected to anything on the bottom anyway, so, well, yeah, oh, well, see if I can clear them from the top. They're not easy. And if you look, you can see here what I did. And this is not uncommon at all. If you look, it took the pad right off the top, separated it from the trace, so we're going to have to repair that. That's what I mean. They used the smallest, most ridiculous traces on some of this stuff. They could have gone bigger. They had all the room in the world, but they didn't. So throughout this video, you'll see me putting this thing I'm taking off, the LED board. I'll be taking that off and putting it back on. I try to protect it. The cables coming off of there that go to the board are kind of fragile in the fact that they'll bend. If you bend them too many times, they'll break right off, and you don't want to do that. And of course, had one screw that it wanted to unscrew from the bottom, not the top, and then it didn't want to unscrew it all. So make that work. The standoffs, or the top screw, was kind of almost stripped in there, but not quite. These don't have any Loctite on them or anything normally, so usually this doesn't happen. Alright, that's back on. So, now we have to do something about fixing that trace. This is wire wrap wire. It's, I think, 28 or 32 gauge, something like that. It's very small. It works really well. I used to do a lot of wire wrapping back in the old days on PDP-11s and things like that. That's how you actually programmed the bootloader on them. Was you wire wrap from place to place in the front panel of the thing, and before you could even load the operating system at all, you had to get this thing done. So I got tons of wire wrap wire. So you take it and you strip it, you put it down through the hole. You figure out where it's going. In this case, it goes right over to the end of a resistor. It's on top of the board there. It's easy to see. Nip it off. And strip it back. I don't have wire strippers for this. I think I still have a hand wire wrap tool with a little slide stripper in it, but I have no idea where it's at. I've actually gotten pretty good at stripping wire with just the little cutters. So we'll tin this guy up and tack it onto the end of that resistor right there where it goes. That's good. And then poke the other end down through the hole. This is a prescribed way of doing it. Sometimes I'll actually rebuild the trace with copper, but this is so small that it's virtually impossible to do that. Got it sticking through the hole. Now we have to do, since the holes are so small to begin with, now what we have to do is get out the capacitors somewhere. They're in this box. I need to buy stock in Panasonic or Nichicon or something like that because I use a lot of capacitors. I've done dozens of these things now. They just keep on coming in. Well, a lot of people like them. I like them. I think there's 14 alone in the radio station I used to work for, and still do part-time. But they're not. They work well, as far as I'm concerned. Some people don't like them. They think that they color the voice too much or whatever, and I don't know. To me, they sound good. And if they're coloring the voice, you're using too much of it, I think, is the problem. Anyhow, so let's see if we can get this thing stuck in here. Make sure it goes the right direction. I think that hole's full. Yeah, it is. I'm going to have to clean that out a little bit more. Like I said, there's no room to play with in there. And just that 32 gauge wire sticking down through that thing is enough to make it really, really tight. Let's try it again. Oh, that went through. Now line up the other side and carefully push it down. Fold the leads over. Make sure your wire's still there, that you didn't break it off, which does happen. And we'll solder it up. There's no pads left on the bottom of the board, so there's nothing to connect to the via, and at this point the via is our wire. And we're going to, I mean, it works about 99% of the time. But we'll give it a shot with the meter to find out. So turn the meter on beep, continuity. And unscrew the board again so I can get to this, what I need to get to. That's a pain in the neck, but you got to be careful with those connector cables. Okay, first for the one that we ran the wire to, and beep, yes, it's good. All right. Measuring from underneath where it's soldered on, and then the other side of the capacitor just to make sure it goes to that resistor. And yes, that's good too. All right. So we got that one done. That was a little more work than I wanted to do. This is how I wind up my wire wrap wire. You run it around till you got a bit off of there. Stick your finger over the top. Go backwards. Stick it back through the hole and pull it, and it stays that way. It's much better than trying to get it into that little slice in the side of the wire case. Anyway, cut them off and move on to the rest of them. Yeah, we'll see if we can get along here without doing any more damage. When you're snipping off leads here, by the way, you only want to take them down to where the lead comes out of the solder. Don't cut into the solder. It weakens the joint and just doesn't look very professional. Anyhow, so that's the big ones. Let's get on to the other ones. This one's 100 microfarads at 100 volts. You have to get the right voltage on these guys too, by the way, because there is some voltage here. Forgot to nip those off to begin with, and these little ones don't give you near as many problems as the big ones do. Okay, now we're going to move on to the 47 at 100 volts, 47 microfarads at 100 volts. So I think there's 4. Yeah, there's 4 of these. Most of them are in the power supply, and there's one over there at the 47 volts for the phantom power. These are pretty easy too, as long as you tin them up first. I'm going to just go through here and tin up all the leads of all the caps I'm going to take out and get it all done at once. That way I don't have to keep reaching for the solder and doing it when the time comes. It's just easier. Yeah, sometimes it takes me a while to find the parts. In this box is different parts for all the different models, and there are 6 different models of this thing, and some of them don't take the same parts. I mean, this particular one's 47 out of 100, and I just got to find it. It's in here somewhere. I know it is. No. Yep, I think. Yep, that's it. Finally. So, now all we got left is the 47 microfarad coupling capacitors. And these are small. Several different sizes that they use in here. If you look real close, you'll see that the outline for the capacitors on the board is much bigger than the ones I'm putting in here, but they're 47 at 25 or 47 at 35. It depends on the model. There's only about 6 volts. Actually, there's some audio. There's one hidden behind this connector cable here. And these guys are not the same as the rest of them. I'll show you here in a minute. These they're non-polarized. Doesn't matter which way they go in. You could put polarized caps in there, but the reason that they use non-polarized is because their frequency response is a little better. Gets up out of the audio zone, so they use them in here for that reason. At least that's my guess. It's not that they've ever told me that, but that would be my guess. Anyway, just clear out the holes and start putting them in. I try to always put them in the same directions. Why? I don't know. It doesn't make any difference, but I do. It's just the way it is. As you can see here, there is no marking for the negative side or the positive side. They are definitely bipolar. So, like I said, it doesn't matter which way you put them in. But they're, like I said, just for neatness sake, and I guess a little bit of OCD, I always try to put them in the same directions. Well, that's all the through-hole caps. So just want to check and make sure I didn't forget any. They're all there. So I guess now the next thing to do is just move on to replacing the switches. I'm going to put this board back on the top here because, you know, I'm going to be doing a lot of flopping around of the main board. Anyhow, yeah, just I've got all the switches cut off and ready to, well, except for one. I forgot that phantom power switch down there, so we'll cut that off. And get ready to do the rest of them, I guess. You'll see here what I do first is I'll go through and solder them all up. Give them all some solder to make it easier to do. And don't forget this one down here. This very seldom ever goes bad, but it's just not worth it. Just do it. And then the one in the middle. This is the one that goes bad most. This one is the level output between mic level output and line level output. The thing is inside. Most people don't even know it's there, and it never gets touched. So it goes. They just go bad. So put your finger on the top there, underneath where the switch push button is. Kind of grab a hold of the sides. lay your soldering iron flat along the side of all three of the pins and just kind of walk it back and forth between the two and wiggle. Don't pull very hard. You don't want to pull the traces out or the vias, the feed throughs. And if you just kind of walk it, it will fall right out for you. It'll just fall out in your hand like that. So, there's one. Let's do the rest. You'll notice on these in the front, I can't actually get to the switch, but I just hold on to the push button part of the switch and wiggle it back and forth and then up and down, and they will come right out if you don't get lost in there someplace. There it is. Works fine. I have tried every other way known to man, and trust me, this is the best way to do it. The only downside is that these switches are no longer good even for a junk box because the leads are too short to go through a board. But that's not the point. Now on this one, you got to be careful. This is the one I was talking about before. The trace is right next to it, and there's a screw in the way, so you can't really lay the soldering iron down all the way. Well, I suppose I could take that screw out, but it still works. There it went. And then this one's got a lot of traces around it too, so you got to be careful with that. Just don't let your soldering iron slip with a lot of pressure. You don't need pressure on any of this. This is just hold it there until it gets hot. It'll stay hot enough on both sides to the point where it'll just pop right out of the hole, just like that. There it is. And now down to the one for the phantom power. This one actually has a ground plane on one side of it, and it's held in there pretty well, so you got to heat it up pretty good to get it to pop out. It looks like the solder sucker cooled down. The thing's got an automatic shut off if you don't use it, so it's not working with me well here, but give it a minute. It'll be all right. Minute, whatever. I have tried using the solder pullet thingies, you push the plunger down and push the button and it sucks it up. The problem with those is it's almost impossible to keep them perfectly still on these pads. And when you push the button, it stands a really good chance of sliding sideways and just ripping the pad right off the board. These things they put it down with Elmer's glue, I'm sure. It's amazing. But this is, and solder wick, that gets expensive real fast. Solder wick is not cheap if you get the kind that works at all. So the solder gun, or the desoldering gun sucker has paid for itself. was like $100, and I've had it for several years now. It isn't great, it isn't perfect, but it does the job for what I need it to do. I have found that sometimes it's easier when using the desoldering gun like this, that if you don't go completely over the hole, just off to the side just a little bit, and that way it uses the edge of the tip on there that has the hole in it, it works better. So if you can get it just off to the edge of the hole with the tip on the solder, and then suck, it'll generally suck it right through anyway. So I've got a tip on there. It's about as small as I can find that will work with this soldering iron. So your mileage may vary from this, but that's the way I do it. Sometimes the solder sucker needs a little help, where you can just get the solder and pretend you're soldering with it, and then once it gets under there and flows, you just give the trigger a push, and sometimes it'll work and just suck the solder right out. So now it's time to start putting the switches in. They're also in the box of many things, but at least they're easy to find. Now, I've got two kinds of switches now. One of them I couldn't find anymore. They're called F2UEEs. And those are the ones I normally got. They're about $2 a piece. And here, this last bunch I got, I had to buy F2UEEDBs, which are they're sealed, and they cost about another 30 or 40 cents. Usually, when you suck these things out, you'll get it just enough so that you can push the switch in there and it'll stay, which is nice. You want to make sure you get it flat on the bottom so that it doesn't. It's not sideways or crooked. Here it wouldn't make much difference, but when you're going through the front holes, with the front panel, it's got to be right, because if it's not, when you push the little plunger button on there, it won't fit in the hole in the front panel. I'm going to use up my old ones first here. I put the sealed one, I think. I put the sealed one in for the mic line switch, since that's the one that doesn't get used as much. The problem with the switches is if you don't use them at all, if you never touch them, then what's on them, the contacts between the little springy things that slide back and forth on the contacts, it flows. And it won't make contact again. And it doesn't matter how much you clean them, it's not going to help. There's just nothing there for it to contact, or what it does have to contact won't mate with what's sliding across it. So your only choice is to replace the switches. And these F2 UEEs are about the only thing I've found the right form factor and good enough to go in these, because I don't like using cheap parts. I don't use cheap parts of any kind. These capacitors, the big capacitors I put in there, I had to go to Panasonic because I didn't have a choice. Parts are really hard to get right now. And I went to the Panasonics. Usually I use Nichicons. That is purely a personal thing. I don't know if Panasonics are any better. They're definitely not any cheaper. But they're what was available at this point. So let's go ahead and just put the rest of these switches in here. You slide it through the little hole and push it down into the pads and start soldering. Well, that's all the switches. So I guess the next step is to start replacing the surface mounts. See, those are the regular switches there. So we move on to the fun part. Okay, well, we'll go on to doing the caps then. I got a new little tool, tweezers for desoldering. They're not much good for soldering as near as I can tell, but they're real good for taking these caps off the board. Hey, look, right on top. Okay, fine. So these are 4.7 microfarads, 35 volt, non-polarized or bipolar service mount capacitors, and they come in these little packages, and in this case we need 14 of them. One of them was loose. There's 13. Snip them off and put the rest back. Neatness counts. I take my packages. If you see me throwing my packages there off screen, that's because I keep those, and then when I go and make up the invoice, I know exactly which packages I took them out of so that they can come off of inventory correctly. I actually have a real business here, I guess, now. Started off to be a hobby. Tin up the leads on that little guy. I'm running it at about 400, 420, 430. Sorry about the head. Because it needs to get hot enough to get these guys off of here. It does take a shade longer than the two soldering iron method, but it is much easier on the board. Your chances of slipping and ripping a pad off are much lessened by doing this. So basically I take them off, then I tin up the little surface mount pads with a tiny bit of solder and a very, very small soldering iron on both sides. Then I put the cap back on. In this case, you'll see in a minute. Oh, there it went. It doesn't matter which way these go, but I put them on the way that the footprint is. And what you do is you heat up the solder that's on the board and slide the capacitor onto it. And then heat the other end of it. And you can feel it when it goes down. You can actually feel it and see it rock downwards towards the board. And when it's on there correctly, it'll be nice and firm and it won't move. And then you get your soldering or your meter set on continuity so it beeps at you, and you test them and make sure they're not shorted because the pads under there are really close together. In this case, it's not. However, in this case, you may have seen that. I put the same one I took off back on. That wasn't real bright. But, that's... Nobody's perfect, I guess. At least it comes off quicker this way with whatever solder they use. It gets hot. I mean, it takes a lot to get them off. But in this case, it should come off pretty simple. There we go. Get it out of the way so I don't reuse it. And go through that process again. Yeah, well, You got to make one or two mistakes every time you do something, right? The biggest problem with this method is with the tweezers, which I haven't found anything better than these 80-degree tweezer thingies here to hold on to them. They get away from you, they fly all over the place, but eventually you'll get it on there. Heat up the solder, slide the capacitor onto it, and then heat up the other side, which you can't see because of my big fat head, but I'm sorry about that. But I got to be able to see what I'm doing. And then rock it up and down until it's good and firm on the board, and then test it. And it's good. So now we got this little bugger in here. This one, I hate this one. It's right next to that switch and that standoff, and it wouldn't matter if the standoff was out of there too much. But you want to protect the switch. This one I still have to take off with the two soldering iron method. I use the really fine tip soldering iron on the left, your left, and the bigger soldering iron on the right. And it comes off of there pretty quick. It's quickly, but putting it on is kind of a pain in the neck too. But you'll see it comes off in a hurry. Don't push, or you'll go right through the pads on the board or the traces, one of the two. Solder, get them tinned, or get some solder on the pads, just a little drop, just a tiny bit. I have experimented with the solder paste, and for these big guys, that's kind of a waste, and it doesn't make that much difference. I use 60-40 tin solder, or lead solder, still to this day. I do not like to the point of hating lead-free solder. It is awful. It looks bad when you're done. It doesn't flow right. No. I still use leaded solder. I'm 70 years old. I've been doing this for over 40 years, and it hasn't killed me yet, so I'm good with it. So we just do the same thing, only very carefully on this one. Back and forth until it seats itself down on the board and it's good and firm. You can tell when it's firm. You give it a little twist and make sure, or a little wiggle like I did there. It wasn't quite down, and you can see it wasn't. It's rocking back and forth. And do it again. The ends of the legs off of those things stick out just enough that you can get a soldering iron down there and heat them up, and that's all it needs. As long as it's firm, you're good. And it's not shorted. All right. On to the rest of them. Now, this one is a pain. First of all, it's very closely surrounded by resistors and capacitors on the board over the top of a THAT IC. And it's just not all that accessible. And it has another little goodie that you'll see here in a minute. I'll show you. If you look at it here, the pads are ridiculously close together. I mean, there isn't a millimeter between those two. The one place where they could have put a smaller trace, they put in a big fat one. So you've got to be really, really careful when you solder this one on, that you don't short it out. If you do short it out, which I did once, the THAT IC gets really hot and dies. And those are made out of unobtainium. I have a few for emergency situations or if somebody needs one, but you want to be careful on this one. It is from this one shorting out earlier when I was first started doing these that I now check all of them to make sure that they're not shorted out when I get done. It's one little extra step just to make sure that you get it don't get yourself into trouble. And ever since that day, the first one that I've done that shorted out, I never shorted another one, but that's probably because I'm cognizant of the fact that it's easy to do. Now this one back here, you got to be careful because those ribbon cables will melt really easy, so you have to hold them out of the way. And if you melt those, good luck. You're going to be hardwiring the thing in there. I had one come in where somebody had tried to do something on it, and they ripped one of those things, and you can't solder them back together effectively. It just doesn't work. So I had to replace it with some wire from an IDE cable, just all bonded together, and replace that whole thing. It was a pain, but it got it done. So be careful of those ribbon cables. They're easily melted and fragile. They'll break right off if you fold them too many times. In case you're wondering, I have my main larger soldering iron set at 700, and that's about right. I mean, for what I'm doing, that's 700 Fahrenheit. The smaller soldering iron that I use just to tin the pads or whatever is 380, 380 degrees Celsius, which is a little high, but you need to melt the solder without being too hard on the board, but you want it to melt. Normally, I will use the big soldering iron to put them back down with. It's small enough of a tip that I can get into most places. On this particular one, I have to use the little one because if you can see that yellow cap, that little yellow 0.01 or 0.1 capacitor that's sitting right next to it there's not much room between that and the back end of that capacitor. So I'll use the real pointy tipped one here, but it just takes longer, and you got to be a little more careful because the tip is so pointy that if you slip, you will go through the traces. So Anyway, 700 degrees, that's where I keep my big soldering iron at, and it does a pretty good job. For all the rest of those on the other end of the board, I'll do them one at a time, and the reason I do that is because I don't want to forget any. If you forget one, and trust me, that's easy to do, something won't work, because these are all coupling caps between stages, between the compressor, expander, and the de-esser, and the graphic equalizer. They're all. If you miss one, you're just not gonna pass from one stage to another, and you won't get any audio out of it. These last four here, these four here, they're all kind of close to each other, so I just take them all off and tin them up, and then put them all back on again. They're fairly easy to get to. This one I'm doing now, you kind of got to be careful because the resistors are real close to it, and you will or can knock those resistors off. There's no big big problem to put them back on again, but just make sure you look carefully after you've taken these off that you didn't disturb something. That's one nice thing about these tweezers is the way they're made. The end of them, the tips, is very pointy, and they go in at that weird little angle, so it works pretty well. Now, these last two back here are kind of a pain in the neck. They're not all that hard to get out, except you can't really get to a good position to put them back in again because they're right next to the plus and minus 15 volt regulators. And these are probably the most important to change. All of these surface mount caps will be bad. I can flat guarantee you that. They will not be good as far as ESR goes, and they will not be good as far as value goes. But most of the time they will at least pass audio. When these guys go, they're the same thing. They're 4.7 microfarads, non-polarized, 35 volt caps, right across the output of the plus and minus voltage regulators. And when they go, what they do is they will oscillate. They'll start an oscillation on the B plus or B minus line on your 15 volts, one or the other or both. And that oscillation can be as high as 20 megahertz. It'll put 20 megahertz sine wave, pretty good sine wave, right on top of your plus and minus 15 volt rail. And that will give you all kinds of weird problems as far as audio goes. You'll get strange hissing sounds. You'll even get some audio with submultiples of the 20 megahertz or whatever it comes out to be. So you'll hear a whistling, maybe. You'll hear tones on top of people when they're talking, or you'll get this almost a pink noise that covers everything. If it comes out to be a square wave, you'll get it all over. So these guys are very important that you replace them. And like I said, they are exactly the same as the rest of them that we just put in here. There's no difference. These you really want to make sure, if you don't check any of the rest of them, make sure you check these, because if you don't, these will short out your plus or minus 15 volt rail, and that will not do good things to the rest of the system. Trust me on this one. Okay, well, that's it. All the caps that need to be changed are changed, which is pretty much all of them. There are some 10 microfarads on there I've never seen go bad. I will check them later, but I've never seen one go bad yet. They're not in use as they're just bypass caps is all they are, so they're fine. But all the switches have been replaced. All the caps have been replaced, both the feed throughs and the service mounts. And we just have some checks to do. I'm putting the caps back onto the switches before I forget, and we'll move on. But I think it's time for a little break. Okay, well, everybody's in and done. I had a cup of coffee, and I think we're ready. We're just going to put a little isopropyl alcohol on here and clean it up some so it doesn't look like I don't care. Some of this flux that we use nowadays, it's not a good idea to leave it on the boards. Although, I remember back in the old days, and I mean old days, 80s, the flux we used came in a little red can, and it was acid core flux. Nobody thought about it very much in those days, but you weren't working with PC boards like this, as fragile as they are. You were doing a lot of point-to-point wiring and with tubes, and remember those things, little little glowing bulbs inside your radio and whatever. So, but this stuff, I've actually seen online from time to time that somebody will say that it's conductive at high frequencies or whatever. It's not something we have to worry about in here, but that's not good either. That's really bad when something like that turns out to be conductive. I remember I was working, I believe it was J.C. Penney's. I was fixing their marine radios and stuff like that because I had a license to sign them off. And I'm just drying this out with a little hot air. And we kept having this one marine radio kept coming back. And we couldn't figure out why the finals on the thing were blown out every time they come back. And they gave it to me, and I did a little research on it and played with it and goofed with it. And finally, after a lot of messing around, I heated up the thermal paste that we were using for the finals, and found out that when it got good and hot, it became conductive. So that wasn't good. Anyhow, a little backstory, I guess. So now we got to hook this thing up and see if it works. I have all the faith in the world. There's the AC cord that'll hold about 10 amps. This should be able to handle this thing, which runs about 10 watts. There is one of the cords, that is the input cord that comes from the function generator, which I have set at 700 hertz and 2.7 volts output, a sine wave. And there's the other connector. This one's, like I said, this one's input. We plug that up into, we're going into the line input at this point. We'll try that first. It goes to the function generator, and the other cord here is the output. It's 600 ohms. It's even marked. It's got 600 ohm resistor inside of that connector there, and it goes to the scope. And then the power cord, slide it up underneath here so that it stays out of the way. I did check underneath here to make sure all the pieces of wire are no longer on the bench. And we plug that into the light bulb, dim bulb tester, just in case. Did something stupid. And then, I got to clean up all this crap. Just get it out of the way. I'll put all this junk into a plastic bag and that I can send back to the guy. It's kind of impressive when you get done with half a dozen of these things and you've got a big giant plastic bag full of parts that weighs about a pound to give him. It's people look at that and they think, well, that's kind of cool. He actually did do something, which I try to do as much as I can. Let people know that I did what I'm getting paid for. So what did we do? We did 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 feed-throughs, 14 service mounts, and 6 switches, or 7 switches. 1, 2, 3, 4, 5, 6. 6 on this one, 6 switches. You may notice that I did not change the switch for the mic and line input switch over there on the left. That's because that's a special switch that is made for them. Anyhow, turn it on, see what happens. And we have lights. There we have a on light. Power light's on. That's a good sign. And let's see, give it a little level. Here come the lights on the level. And I guess let's see if we can get the scope up here and see what it looks like. There we go. There's the scope. My scope doesn't look like that. That's the camera doing that. Turn it up, turn it down. The pots are good. There that pot is anyway. We checking the The equalizer, make sure that it does what it's supposed to do as far as going back and forth, up and down, whatever. I got 700 hertz going into this, so that's the high frequency. That does quite a bit. There's mids. That does a lot. And let's see. Take that back to neutral somewhere. Neutral. There we go. And then go for the lows. Yep, lows work. That's why I use 700 to do these, because it works on all three parts of that equalizer. That was the voice symmetry. It looking good. This is the compressor expander. It looks good. Lights are working. Now if I turn it up, turn down the input, the lights on the, yep, there's the expanders working. It's coming in. And let's see, this is the, turn that off, and this is the de-esser. 700 won't do a whole lot on the de-esser, but it's working, the lights work and everything. So now let's switch over to the mic input. What I got here is a 50 dB pad to take line level to mic level. Those aren't cheap, but you got to have one. And that we just plug the line level into that and into the mic input over there, right there. And push the mic button, and we should have level. Turn it up. Oh, that one's dirty. Yeah, that pot's dirty. I don't clean pots anymore as a rule. Because cleaning them with the deoxit or whatever has a tendency to make them wear out faster. If you don't have to do it, don't do it. And now, even when I do it, I use the F type for faders, because it has a certain amount of lubricant in it. It's not as fast as far as cleaning as far as the deoxit regular goes, but it does a fine job, and it doesn't eat up the pots. So that's working now. When you do these pots, you got to remember it should be on 50 or 60 on the front, because you're amplifying 50 or 60 dB depending on your microphone. So that works. It looks good. All of the pots work. All the switches work. And now let's see. If I take the output here, I'm going to run it over to the distortion analyzer, and we'll take a look at that and see how it's doing. About the best I can do in this room with all the crap and wall warts and lights and LEDs and everything is about 0.1% distortion. All by itself, just sitting here, is 0.1% distortion. So let's see what it looks like here. There's the meter. I've got it set at 700, and we'll turn it down a little bit. Get it in closer. There we go. Do the null it down. That's pretty nulled. Crank her up a little bit. Do some more nulling, and then do some frequency. Adjust the frequency to get it about as close as I can, which is right about there. Oh, a little more, and then a little more nulling. The new distortion analyzers do this for you. So let's tweak it in as far down as I can get it. And that's about it. I'm on 0.3, full scale, 0.3% distortion. And our meter is showing about just a shade over, well, 0.2 or something like that. I could get down a little lower if I messed with it for a long time, but that tells me that the distortion level is quite good. That's fine. So, one last test to do here, as far as the main test that I do, and that is I'm going to crank it up as high as I can as far as input and output goes, and get it to get the red LED to light, which means that you're overdriving the heck out of this poor thing. And you'll want to see if we don't have any distortion on the meter. So let's give that a shot. That little thing I was doing there was just testing the 20 dB pad or 15 dB pad, and it works. And let's show you here. I'm going to crank this thing up so that the red light's lit on the far side, and that means overdrive. And take a look at the scope, and no, it's pretty. The op amps aren't being overdriven, especially that output op amp. So everything is good. This works. Now all I got to do is go through and do the measurements and everything and make sure that everything is right. And one of these days I'll make a video on that. But this video is plenty long enough. So hope you learned something and hope you didn't fall asleep. So, hey, thanks for watching. Don't forget to, ring the bell so if I'm doing more of this stuff. And we'll see you next time.